Welcome back, everybody. This is just another testing the what do you call it, the camera, um, and see the choppiness of the camera while I play some YouTube in the background. So I put up a second monitor here today, so my interaction window is a little bit bigger, and we'll just go through this here. So I just put into the search field, I just put in flu, and we just look through these here. We got flu virus 101, National Geographic 2 years ago. Influenza, the flu 7 years ago. Cold or flu 2 years ago. How does flu make you sick 1 year ago? How to tell flu from cold 1 year ago. Treatment for flu symptoms 3 years ago. Bird flu epidemic 2021. Everything you need to know about bird flu, avian influenza 1 week ago. How the world bounced back from the Spanish flu. The Spanish flu, hola, and how the world recovered. History documentary, history time. Top 10 worst epidemics in history 5 years ago. Killer bug SARS coronavirus 6 years ago. We got our little spiky friend there. The flu vaccine. So is my window choppy? It is kind of still choppy, isn't it? So I'll try, if this crashes on me now during mid-stream, or not stream, mid-record, forgive me. But I'm just going to see, can I open up settings while I'm recording? That'd be neat if I could do that. I can. So I can't see you guys now at the moment, which by you guys I mean myself. So I think what I'm going to do is, okay, go to recording. CBO 2005, ultra fast profile. That's baseline. That's supposed to be high. I heard from the guy, one guy say. Put that to none. Can't think of much else to do on that. You have unsafe changes. Save the changes. How is that? Is that still choppy? Is it a bit more fluid? Bum bum bum. Still a bit choppy, isn't it? Still a bit choppy. Anywho, doesn't matter. So we go through these here. Know the symptoms of the flu 1 year ago. Noam Chomsky. Interesting. 97% of people need to start asking this question. COVID-19. 97. Very accurate number. It's amazing how they get these accurate numbers. So, deadliest plague of the 20th century. Flu of 1918. The Spanish flu. Estoy. Life cycle of influenza, that was 10 months ago. We've got our little ball friends there, Spanish flu again. An old picture with the furry pictures of that up on top of it. Why does the flu come back every year? By Seeker. Let's just hear what Seeker has to say about that. Hey, where'd it go? Yeah, there. Can I? Okay. Okay, I can only click on it. Oh, there's no. How am I going to go back on this?
Should this tactical zoom lens be made illegal?
Oh, stop.
This is the first reasonably priced monocular.
God, the voice is even weird.
Flu has become a slang term that refers to almost any ailment where you just don't feel quite right. But influenza proper is a handful of specific viruses that invade the respiratory lining, evade the immune system, and mutate at a rate that even the world's most brilliant doctors, scientists, and health organizations struggle to keep up with.
Incredible.
So what is influenza exactly, and why does it always seem to be one step ahead of us?
It's hard to know.
Some of the confusion around the term flu may stem back to the word's roots. Influenza is an Italian word that just means influence.
Because back 500 years ago, people didn't know about germs then. They thought if you got this disease, you were under the influence.
That's right, germs, you know. Right around the time of the Second World War, when the entire world was at war with Germany. That's when the word germs came into being. Edward Bernays, go look him up. I'm doing a video on him.
Perhaps of the stars or something else. My name is David Morans. I'm a medical doctor and an epidemiologist and a virologist and a historian at the National Institutes of Health.
David Moran.
And an officer in the United States Public Health Service. And I'm here today to talk about one of my favorite subjects, influenza.
Influenza presents with such iconic symptoms that many other diseases are classified by their similarity to it. Tell your doctor you're experiencing flu-like symptoms and they'll know exactly what you mean. Coughing, fever, head and muscle aches, fatigue, and well, just general malaise.
Which kind of means just feeling really bad. Anybody who's ever had...
Which kind of just means feeling really bad. And this guy is a top doctor. It just kind of means feeling really bad.
Who knows what it is.
But while many illnesses are similar to influenza, there's only one true flu. Well, 4 actually. And trying to put a finger on the countless variations and mutations is actually where influenza starts.
4. They've narrowed it down to 4, folks.
Starts to get the better of us.
Well, depending on how you cut the cake, there are billions and trillions and zillions of different types of influenza. But to start, we categorize them into 4 categories: influenza A, B, C, and D. The ones we're most interested in because they affect humans every year are A and B. C also infects humans, but it's pretty much a minor disease that affects children. And D is mostly an animal disease that people generally don't get, or at least they don't get symptoms from it.
Influenza A, B, and C for the kiddos start by entering your upper respiratory tract, either when you breathe contaminated air or touch your nose and mouth after coming into contact with the virus.
When you breathe contaminated air. Contaminated air. Where is this contaminated air? Where is it around you? How do you know it's there? How do you know when air is contaminated?
The only cells that really affect are what we call respiratory epithelial cells, a one-cell layer of cells that kind of protect the breathing tube and the lungs all the way down to the bottom where we have air sacs. Those lining cells are the ones that get infected.
Once they reach your respiratory lining, the virus is attached to a specific kind of cell receptor called sialic acid.
But you can see them up close. They look like branches of trees. They stick out and they go in all different directions. They kind of capture things, and by binding to it, it can be dragged inside the cell where it causes the infection.
The influenza virus then makes its way through your respiratory passages, in rare cases reaching all the way to the bottom of the lungs and leading to severe pneumonia. All this suspicious activity would normally cause your body to launch an immune response, and usually it tries to. But this is complicated by the fact that the virus and the immune cells coming to the rescue...
I want you to look at those, the shape that they present the V as. The hybrid. Look at the shape that the classic shape, right? Well, it's classic now because they've been making it, they've been putting it everywhere, visually for everywhere for everybody to see. Now, especially to do with what's happening right now. But look here, look at the shape that the flu is. Okay.
Are separated by that epithelial barrier.
That's one of the reasons it makes it hard to develop strong immunity to flu, and to raise strong immunity by using a flu vaccine.
And as if that weren't enough, even if you are able to mount a defense of some sort against the virus, influenza...
So there's a little wall, basically. There's a little wall with another little something on the other side, pushing against it like that. Look, we'll go back and look at it again, right?
Invented several thousand more versions of itself.
Okay.
Response. And usually it tries to. But this is complicated by the fact that the virus and the immune cells coming to the rescue are separated by that epithelial barrier.
That's one of the reasons it makes it hard to develop strong immunity to flu and to raise strong immunity.
So there's an epithelial barrier which basically stops our immune system from engaging with the flu. All right. So this thing called the flu gets into your lungs, can do it at once, do its thing, and yet your immune system can't get to it because of an epithelial barrier, right?
By using a flu vaccine.
And as if that weren't enough, even if you are able to mount a defense of some sort against the virus.
Oh, even if you are. Even if you are. So there's even if you are. There's an even. So even if you are.
Influenza has already invented several thousand more versions of itself before you can blink an eye.
Well then, it's invented several thousand versions of itself. How did they find that out? Several thousand. They have 4 definitions, they say, at the start of this video. Yet they also can determine that there are several thousand.
The influenza viruses are not stable things. They're always moving and changing, day to day, hour to hour, minute to minute. Mutation is all they can do.
We can never get it under control. We can never get it under our finger. We can never get it under our thumb. The flu.
There is no state of their existence in human beings that is not.
Look at the visual representation of the flu V on the left there. Okay. Again, it's shown as a ball with little appendages, little kind of suckers or so-called the things which because I'm going to show you something in a second. Okay.
Constantly mutating.
This is because
Constantly
of the machinery
mutating.
in their RNA that causes consistent errors in gene replication. But unlike for humans, these errors actually work to the virus's advantage.
They're good errors that help them to survive. Even in your own body, if you are infected with an influenza virus today, you're not going to be infected by one virus. You're going to be infected by, let us say, 1,000 or 10,000 viruses.
Well then, just give up right now, eh?
And it's this rapid-fire mutation that makes whipping up a vaccine for this set of viruses a pretty tall order. Each year, researchers from the World Health Organization and around the world develop one vaccine for the Northern Hemisphere and one for the Southern.
Oh, one for the north or one for the south. Oh God, guys. Like when you begin to see it, it's just ridiculous.
These vaccines are released 6 months apart to coincide with winter's flu season in each area. Their recipe is slightly...
In each area, north and south, divided by a line that goes around the world. So they have a vaccine for the flu, solely for the north, never mix it with the south. And the vaccine for the south, you never mix that with the vaccine for the north. Let's keep going. This is interesting stuff.
And can be tailored for specific types of patients, like the elderly.
The current vaccines have 4 viruses, 2 influenza A and 2 influenza B, and it may or may not work because in the meantime, the viruses circulating around the world may have mutated to the point where your best guess vaccine is worthless.
May or may not work.
So the scientists have to guess now
Yes.
what vaccine they're going to need 6 months from now.
They have to guess. The scientists have to guess. So, like, the scientific method apparently is, that you isolate a particular observation, discovery. You replicate it a number of times, and you isolate the fact that you're able to do so. And then you ask others to do the same thing in other places, other scientists. That's as far as I can remember, that's the scientific method. Okay. Let me go back on that again.
It's like looking into a crystal ball.
And in addition to this seasonal cycle, every 3 decades or so, the stakes ramp up, and the disease is dramatically more hostile, causing a pandemic.
A pandemic.
Years we have a pandemic, as many as 50 or 60% of all people might be infected within a year. That virus causing the pandemic can come at any time of year. Eventually, we don't call it a pandemic anymore. We call it a seasonal virus.
But all...
Am I the only one constantly hearing corrections here, contradictions? He said it can come at any time of the year, but then it's seasonal. Is that not an inherent contradiction within one sentence? Let's keep going.
All over the research continues on influenza, and the hope of a universal vaccine could be in sight.
A lot of scientists, including NIH and CDC, are working very hard on this. And every year, all over the world, thousands of influenza viruses are being taken from patients and sequenced. This gives an idea about what direction
those East Asians, we really have, like, they're so studious that they're the ones we must rely on in order to knuckle down onto the thousands of variations. Only can these guys with their numerical mindsets be able to do this. They're moving the little sliders on an abacus from the moment they pop out of their mammy's womb. So these are the guys. That's why they're on the screen there.
Evolution of this virus is going. By learning how the body can successfully control influenza, we have a better idea how we can mimic that for vaccines.
But in the meantime,
don't walk, run, and get your flu shot every year.
Don't walk, run, and get your flu shot every year. Okay, so we'll go on now. We'll look at something else here. I want to show you something. Now, some of you might have heard this already, and some of you may not. But we'll have a look together. And you let me know if my video is being choppy. So, this is an interesting little thing to look up called exosomes, okay? And exosomes have been, they've been researched and looked up for the last, look, there's one. What are exosomes and why are we studying them? From 7 years ago, okay? Exosomes, pathway creative diagnostics. Flesh-eating bacteria is real, and this is how it works. Seeker, without you, what would we do? What would we do without this information? Disinformation. RNA profiling of exosomes. Yeah, I think this may be okay. It's a bit long, but we'll just go into it and have a quick look. There's no back button on my interaction window here, so I don't really know.
Hello everyone. The title of my presentation is RNA profiling of exosomes. Why we are also excited about exosomes. So you know that these fascinating vesicles gained a lot of attention within the last few years, and there are three main areas of
research. I'm seeing it too.
So first of all, a lot of people are focusing on fundamental aspects. It is extremely important to understand their pathways, functions, and network. And clearly, at the moment, we have some idea about that, but it will probably take another 5 to 10 years to unravel all this mystery, because we're just scratching the surface. And it's extremely important to lay this foundation for future progress into the applied side of the things. But at the same time,
most likely gone there. Pathogens in exosomes. Was that 2 years ago? Curiosity as the cure. Misinformation. Of course, misinformation. Exosomes in naturally occurring vesicles. Okay, so this is it. We'll have a quick look at this one, right? God, my thing is so
about something different, something that most of you have never heard of whatsoever, and it's called exosomes. And I'm going to talk about what they are and why they're relevant for this discussion. So exosomes are something that is naturally occurring in the body. So I have this diagram here, and if you look at the top right of the diagram, you'll
keep an eye. Look at the visual representation of what an exosome is. Isn't it very interesting?
See that this is a normal cell here outlined, and inside the cell you have these vesicles. And inside of our cells there are a number of different little organs, they call them organelles, and they're generally contained by a membrane. They come in different shapes, but lots of them are in this structure. It's essentially like a spherical blob that has the same membrane as is the outer membrane of the cell, a lipid bilayer membrane, and it can contain various types of chemicals. Now, this is a...
They're fascinating things, exosomes. Like they're the body's natural way of communicating within itself.
Specific type of vesicle that will end up merging with the cell membrane at the surface under certain conditions and release these exosomes out into the extracellular fluid, and they'll get into the circulation and be distributed around the body. So while
I have to laugh because over in the suggested videos from Bloomberg, is a Bloomberg quick take, the rise of the flying car is finally happening.
they're inside the cell, they're called MVEs, which stands for multivesicular endosomes. So in other words, they have a bunch of exosomes or vesicles inside them. And they release these on a regular basis, just day to day. And there are many things, though, that can induce this process and accelerate it and increase the number of exosomes.
Yeah, it's gas. Yeah, the choppiness is gone when I stop or pause the video. I have to figure this out because I'm looking at my own window, and the bittiness when I'm playing the video is quite noticeable. But you know, you can still see me. But I want that to make that as smooth as possible before I even approach live streaming, you know?
That it releases outside of the cell. And so these exosomes leave the cell, and you see they have these little squares on them. And these little squares are like a lock. And what they do is they go around the body through the circulation, and they're looking for the right key to fit their lock. And that's called the target cell. And depending on what kind of cell releases them, they might have different keys and different locks, so they're targeted to different parts of the body. And these are mostly thought to involve communication. So communication between one cell and another cell, between one part of the body and another part of the body.
I just think that is so fascinating that within your own body, your cells are communicating with other cells within your body.
And they can have many functions in this communication, which I'll get to momentarily. So here on the left...
Again, I ask you to take note of the visual representation of the exosome.
This is an electron micrograph, or a picture from an electron microscope of exosomes. And you can see here an exosome budding out of the cell. And it's essentially a spherical or circular, this is a cross section, so this is like a slice of the tissue, where on the periphery there are like these kind of globular densities or little dots or circles, right? And inside the cell here where it says MVB, these are the same as MVEs, that's where all of these exosomes are when they're inside the cell before they bud out. Okay, and now we have a picture on the right which allegedly shows this COVID-19 virus. And you can see that there are these
allegedly
these vesicles budding out of the cell in a circular shape with these globular dots on the periphery. So essentially it's the same thing. Now you might think that this looks a little bit fuzzier on the exosomes and it looks a bit sharper in this picture. And I want to tell you that the reason for that is because when you're cutting these thin sections of tissue to make these slides, you're using this device called a microtome. It's like a vibrating razor blade. And it's technically difficult, and sometimes the tissue doesn't cooperate well, or sometimes the person is less skilled. And you might...
So I don't know, you know what I mean? I'll put a link to that video in the description. But the thing about it is... it's a fascinating video, and whether it's real, whether it's false, is up to you to actually decide for yourself. I understand that there are many layers of deception, and there are many layers of manipulation, and the manufacturing of consent. All I say is keep an open mind, and if you let other people think for you. This is what my channel has always been about. I've always wanted people to think for themselves. I'm not here to tell you how to think. I'm here to show you that it is okay to explore. It is okay to genuinely keep your mind open. And it is also okay to fall on a decided thought about something. I know it's all obvious, but what I'm saying is it's okay to keep searching, hold a thought and say, this is what I believe, this is my opinion, this is what I believe I'm seeing, this is what I believe I understand, but I'm still open to being wrong. That's all I'm saying. That's all I would like to see people to do. That's all. I'm hoping that in my channel that I'm helping to teach people how to think critically and to learn how to use their minds to actually continue to think, and that it is okay to fall on a particular line of thinking and to say, this is what I believe, but then also to think I'm open to new information to add to that and maybe change that at some point in the future, but not without evidence, not without having done definite research and understanding. Okay, so I'm just going to leave it there. I think I've been recording for about 27 minutes. So again, this is just a little exploratory video, a little bit of fun on the screen, and I'm trying to get that choppiness out of my window. I'll do it. If it's the last thing I do, I'll do it. All right, take care. Have a good evening, everybody, and be well. Breathe deep and breathe in God's good air. Okay? That is good air, oxygen.